Good evening to all of you. We have reached to the last module, module 10 of Systems Engineering and Applications program. So this module is particularly about designing flexible systems. So far we have studied a lot of concepts related to systems engineering like systems approach, systems thought, then systems thinking, then we have seen the utilization of different other concepts like optimization, quality management, then the axiomatic approach, right? And then we have seen how the design structure metrics, model-based systems engineering, and the system dynamics modeling can support in the systems engineering domain. So now we have reached the last module where we'll be discussing how to design the flexible systems. Though we have already seen some of the flexibility in model-based systems engineering, where we have seen that how the RFLP approach can be adapted in defining the things in a system so that the logical relationship will be clearly defined and then it will be easy to change in those model-based systems description. So we'll see today that what is the how to design basically the flexible systems. So the basic approaches are about the ability of a system or a product or a process to adapt the changes. If I say a engineered system is getting an upgrade, maybe for any of the input or any of the operating system or any of the raw material update in that particular instrument or in that particular engineered system. So in that case, sometimes we may need to scrap the product and adapt the new one. But in most cases these days, most of the companies are practicing the design flexibility, and that is the reason why we are getting new and new products more often than 2 decades before. The reason is that every time they don't need to design from the scratch. The designs have been created or have been developed in such a way so that if I would like to upgrade any of the one segment of the product, it can be easily done, right? So that allows the manufacturers and the designers to come up with a new update, but with the least cost, minimum time, and least efforts. And now it has become an essential quality in the supply chain management, engineering domains, all engineered products, right? So this is how we have to make sure that designs can adapt with the changing requirements. New technological advancements can be embraced easily, right? So the way we are living in the fast moving technological advancement domain, or you can say uh, the fast moving pace of the technological advancements. Industry 4.0, we all know, right? Several technologies are involved, like IoT sensors, cloud, then big data, then 3D printing, then augmented reality, virtual reality. All these technologies we are utilizing. And every time the form of that technology is getting upgraded, new and new versions are upcoming. For example, you may take an example of your cell phones. The same cell phone is getting upgraded with some of the features, and a newer model is now in the market. If you see the upgradation of operating system in your laptop or in your cell phone, what happens? Do you need to purchase a new cell phone to upgrade the operating system? No. What actually happens? That you need to upgrade that operating system in the existing cell phone or laptop. If someone tries to say that there is a particular issue of the chip, chip design has been changed. So you need to just change the SIM card design. If somehow the SIM card design has been changed, which cannot be fit in the given slot, in that case, the slot requires to be changed, but it may not be able to compatible with the remaining design or remaining structure of the mobile. So in that case, you may need to replace the older version. Most of the cell phones could not, support the 5G systems, or some products are there which do not support the Bluetooth connections. So in those cases, when the Bluetooth came, and or you can say when this 5G got introduced, multiple people have to replace their cell phones, right? So this is how it depends that how much or how, I mean, it is kind of future possibility, right? Like whatever you are designing today, there should be a possibility or a scope to upgrade the existing products in future. So let us see. In the organizations, they're focusing on design flexibility because of rapid technological changes and market shift. Customer requirements are also changing with time, right? And you see, a well organized, flexible design actually reduces the likelihood of obsolescence, right? It supports the minimum wastage within the given particular product. You may get the upgradation without changing the whole product. So this is how multiple people can adapt the innovations easily. Importance of design flexibility. So how important it is. So some importance you already get, but you see, it increases the flexibility, right? And this increasing flexibility eases the evolving needs adaptation, right? So if I talk about the importance of design flexibility, you see, it increases the flexibility to meet evolving needs, right? Expenses got lowered down. You don't need to redesign everything from scratch. Then the life cycle or usability of the products increases. If the usability in the product life cycle gets increased and you are upgraded with the existing technology, we could rather say that it promotes the creativity and supports the technological shift. The occurrence of risk and uncertainty in the market conditions may be managed, right? So this is how the flexibility is very important. So now we'll see some examples that how it is important. Usually, when we talk about design flexibility, or when we talk about designing a component, you already have seen some example like stapler, then the vegetable peeler, chemical scrubber. Professor Pandey has discussed all these three products in detail, right? How these systems work, how did they, designing of this product has happened, and then how what are the insights about these systems. So I would like to just bring into your notice that the standing wheelchair. Wheelchair is something which we always think of, use is just to sit, and for a longer time wheelchair was utilized by people who are disabled or who are unable to move due to older age or maybe any other reason, right? But in the last decade, people observed those fellows who are using the wheelchairs, and their pain points have been mentioned by interviews, by discussing, or just by observing that how their life is, by just creating their personas, right? Their pain points. The requirement has been found out that this particular requirement of standing is still a pain point. They are missing that standing body posture. There are multiple house sports, or there are multiple personal works they can do by standing, right? And when they are able to stand with this particular structure of the wheelchair, it will be useful for the users. So now you see the design flexibility of a wheelchair, a chair which is supporting the standing posture, and a chair which can support the the sitting posture. Both the postures can be supported by just make the design flexible to make the flexible products, right? And these are some of the, like this, there are multiple products which are happening or which people are making these days, which are very useful for the target, users. And the flexibility in the design, the customizability, the technology upgradation can be easily done for the different parts, right? So you don't need to scrap some particular product. If one, you see, every component of this particular wheelchair is actually modularized. And if there is a upgradation, some part broken out, then you can just replace one particular segment. You don't need to throw this particular product or replace with the new one, right? So this is how the flexibility can be involved in the designing for the flexible products and the flexibility in the designing. Now I would say that if a customer is of 50 kg weight, 5.5 a feet of height, another customer may be 90 kg of the weight, 6 feet of the height, right? You may require different kind of requirements in the chair. The size of the chair, the load capacity of the chair or load capacity of the wheels also requires to be updated, right? Or changed. So how will you do? Will you design a totally a new product for this new customer every time? No, it's not possible. So if your design is flexible, you may very easily make these changes which are customizable. What customizability is itself showing that the designs are flexible, right? If the designs are not flexible, it will not be possible at all to redesign for each and every customer different times, right? So this is how you see these are the examples of the flexible designing. You share your features, so you share your characteristics as a user, and then they will customize this product for your requirement. So this is a very good example for the flexibility in designs. This is how they are coming up into the market or into the customer with the different characteristics and different requirements. Now you see it's a very, I mean, I like this product a lot. The thought behind this product is really, very, you can say the novel, or you can say the systems engineering concepts have been applied so well in this particular product. So when I saw it, it's a product which is developed by IT Madras. You see, this particular product is basically a electric vehicle come wheelchair. User can use it as a wheelchair, and if user wants to move out, it can be attached with the front motorized EV component, and then it may be used as a vehicle. If there is a problem related to you know the the vehicle part, or you can say the speed related issues, or some or the vehicle related issues, then you can just change the front part or any of the sub module which is not working properly. So this dual kind of flexibility itself is showing that how they have prepared this product for the disabled people who are unable to to walk properly, or they don't want to take someone's help in going out of their homes. They can easily utilize this kind of products. And now once again the similar concept is coming up. It's a customizable product depending on your height, depending on your weight. It can be, or maybe the load capacity, or different other parameters. This can be customized very easily. And this product is the first indigenous motorized wheelchair vehicle, Neo Bold. which has been developed by IT Madras for different set of people who can make it use for their different customizable utilizations, right? So this is how these are some products which are showing or expressing the utilization of flexibility in systems. So these are, I'm just showing these examples just to make you understand. Definitions everyone know, right? So I just want to express that how do you exactly understand and inculcate the thought of product development of such type where the design flexibility is supreme, right? So your thought should be aligned, your systems engineering thought along with this product development thought must be aligned, right? So this is how the design flexibility we have to think of. So moving to the next, thing, that is the characteristics of design flexibility. It is all very clear so far that what is design flexibility and how we can include the design flexibility in different products. Examples we have seen. Now the characteristics of design flexibility is like modularity, then scalability, then the reconfigurability. If you see what is modularity, as I already explained, dividing the component, dividing a system into different segments or different parts, right? So if a particular module or sub module got failed, you can replace it. As simple as that. When you say modularity, one popular word is modular kitchen. I hope in everyone's house these days you must be having modular kitchen. What does it mean? You can do it yourself, right? There are different parts of those modular, the wooden parts, or you can say the metallic components are there, which you can easily channelize, right? Or I should rather say, which you can very easily assemble together and put it in the place for your use. And if, let us say, one component got broken off, you can replace just one part of that particular setup, right? So systems can be divided into different parts. That is one way of, thinking for the design flexibility. And then you may easily add, remove, or change the components without impacting the whole system. One very good example is, these days in laptops or in your, the CPUs, we always get the slots to increase the RAM. Long back, I remember my very first PC, the CRT cathode ray type, the Dhanbad PC, right? So in that CPU, the slots were not there. If you want to increase your RAM, the additional slots were not there. And that is the reason why that most of the cathode ray tube based computers got obsolete. And the CPUs, long back, if I talk about 2 decades back, the CPUs were rigid design. If you want to increase your RAM, it was not possible to increase. But these days, if you see the CPUs or even your laptop designs, there are free slots. Additional slots are available to fix the RAM so that to increase the RAM if you want, right? So this is how the design flexibility is changing with time as well. Scalability. Scalability is all about the design should be some in such a way that it may change according to demand. The very best example of scalability is like cloud computing solutions. If you want to add one user, you may add one. You can make it scalable up to 10 or 100 users also, right? So this is how it's a very good example of the scalability of the designs, right? So someone may ask that what is the scalability in the the tangible products. Then we'll talk about reconfigurability. Reconfigurability is something simple part replacement without requiring a major redesign. As I already gave you an example, adjustable workstations, right? You don't need to replace the whole, system. You just do some small part replacement and the whole system will be upgraded. Other characteristics of design flexibility is standardization, which is already happening, right? But when we become the system engineer, or when we will think about a flexible designing of engineered system, we have to keep this thought in our mind also. Standardization, right? The role of standardization is that, let us say, I am using a cell phone today of, let us say, version 5, right? Some brand X version 5. And after some months, there may be same brand, same cell phone, but version 6, right? So now from version 5 to version 6, upgradation have been happened. But those who are using version 5 of that cell phone, and now let us say some component got broken, and I would like to replace that component. So most of the people who can help in repairing can immediately say that this version 5 is now the older version and we do not have the components to replace it in your cell phone. We cannot repair it. It is irreparable, especially when a new upgrade of the same brand comes up in the market. Why does this happen? That this is a very old component and these parts cannot be replaced because this is the obsolete version. Newer versions are there in the market, so better buy the new version. The components cannot be replaced. This is due to the less standardization, very low standardization. What is standardization? It is making use of commonly used elements and interfaces. Even one very important thing I would like to mention here is that if you go, let us say, brand X version 5 you are still having, and in the market version 6 and 7 are also launched, and if you would like to change your cover of that cell phone, even then you will not be able to find that. Why? The lack of standardization, right? So if I would say that the standard components are utilized, then it will be easy to increase the life cycle of the products, right? And it will be easy to make it more usable for a longer time. And in another sense, I could say that it will be more sustainable, right? So in the standardization, it improves the interchangeability and compatibility. Similar part can be utilized at multiple places, like USB ports. USB ports you see in any laptop, in any pen drive, and this is a standard size, and everywhere it can be compatibly utilized, right? So that is one very good example of standardization. So this is one very important, definition of standard parts. Standard parts are also known as standardized or off-the-shelf parts, which are readily available components that are manufactured to be used for a specific purpose. These parts are usually used across multiple industries and applications. So I'll show you some examples of standard parts. Standard parts is a common term in most factories, or you can say especially in the manufacturing units, where these parts have been categorized as standard parts, and it doesn't matter which product you are manufacturing or which particular module or segment you are manufacturing, you may utilize these particular parts anywhere, right? So very common standard parts which you all are aware of: fasteners, screws, nuts and bolts, rivets, right? So these are such standard parts which can be utilized in multiple industries actually, or in the table, in the chair, in the in the air conditioner system, or anywhere it can be used, multiple places, right? Then another standard parts are connectors, very common. Either your electrical system, hydraulic system, or any pneumatic system, you can utilize the connectors. Different diameters of the connectors are there, right? Different size, different diameters, different kind of angles also, and that can be utilized at multiple places, different places, different industries, right? Different targets or different aims. So this is how connectors are also very important standard parts in which can be utilized in multiple industries. Then the mechanical elements. Though the utilization of mechanical elements is limited, but still it is very commonly available and very commonly utilized in multiple mechanical manufacturing units like gears, bearings, springs, hand wheels, hinges. See, gears is really very important component in mechanical elements which can be utilized as a standard part. Multiple utilization of this particular gears. Then you see the electronics standard parts like CPU, hard drive, batteries. Batteries are very common. You have seen that pencil cells, small batteries, even then can be utilized at multiple places. If you talk in the context of industry, you will find different kind of battery capacities are there, and that can be utilized for multiple purposes in different products, right? Then particularly in the automotive segment, if you see oil filter, fuel pumps, air filter, fuel tanks, these are all the standard parts which can be used to be replaced in any of the automotive product. Then for the building or construction domain, pipes, fixtures, connecting devices. So this you see, these all are the images which are used to illustrate the examples, right? So if you see in all these standard parts, it is very clearly mentioned that these are the crucial components. So if I talk more about the characteristics of design flexibility, the robustness, and the future proofing, these two are the most important concepts. If your design is not robust or not ready for the future proofing, it will be a question mark, right? Because in this era, especially in this 20s, you can say we are moving very fast, especially in the technological advancement domain. Every now and then we are having new and new technologies, especially the AI based developments are at peak. And if we do not prepare our designs robust with the future proofs, it will be very difficult. So now, what is robustness? Robustness is basically a system's ability to function effectively in whatsoever condition. It should be independent of the external environment, right? So robustness is the capacity to function effectively under different situations, right? Different situations means, for very good example, is all-terrain vehicle. It vehicle should be capable of moving in any of the surface, smooth, even, uneven. Right? It cannot be defined that a vehicle will be moving in the even space in even surfaces always. If you move it to the uneven surfaces, it will not be function. So then there is no use of the product, right? So we always try to make the products robust, and we in our designs, by having the systems engineering thought as a whole, my product, external environment, then how the system of system will be behaving, everything will be considered properly to design a robustness of a product, right? So you see, when you design any system or organization, it should be adaptable, scalable, resilient to all those external changes, right? So if I talk about robustness more, I should rather say it basically ensures the reliability of the product in the variant external environment, right? External environment is changing all the time. So it will help to prepare the reliable product, right? Then the future proofing. Future proofing is something which anticipates and prepares for the longer term. Today I am using this particular, or let us say today I do not have any AI in my system, but tomorrow I may need to have a dashboard where AI can help me to calculate all the predictions about the fuel condition, about the speed, about the possibility of accidents, about the upcoming issues. So that is called the future modification, and which includes elements that predict the future modifications. Right. So I think with this, I would like to say that robustness and future proofing is something which is very important feature of any product which you are designing now. Though we in this, as I told you that in 2020s we are facing significant change in the technological advancements, or we can say that in 2020s we are facing the rapid change in technologies, and this rapid change actually motivates us to develop some products which are robust and will be working in the future scenario also, right? Whether it's a tangible product or intangible services or processes, they should be capable of changing with the requirements of customers or with the requirements of the technology. It should be capable of, right? The example of 4G and 5G. When the 5G entered into the market, what happened? This technology was a revolutionary technology even then, and multiple people have to replace their cell phones. Why? But most of them were not, because some designs were flexible, were more robust. It doesn't matter whether it is 4G, 5G, 6G, 8G, doesn't matter. You don't need to replace the cell phones because they have prepared that products, design the products in such a way that they are adaptable with the changing needs, right? But some of the products were required to be replaced completely. So multiple, if you see in the angle with the angle of sustainability, it may be a challenge in upcoming time if you do not design the robust and flexible products. So now the one question I would like to ask here in this, it's a thought-provoking question, that what is the relation between robustness and complexity of a product, right? Or I should rather say, what is the relation between the design flexibility and robustness, or the design flexibility and complexity? So if you just try to apply the axiomatic thought, you may understand. So now I'll discuss some cases related to the roles of systems engineering. Some of the cases, I mean, some of the products and their design you have already studied, right? Very important case. If you remember in the introductory class, Professor Pandey has listed this case as to illustrate that what is the role of systems engineering and why it is important to understand the systems engineering, right? If you think about a particular product as a as not a part of system, how the things can be chaotic, or you can say the fatal. So let us see this case. This case is about the ignition switch issue which has happened in some of the cars produced by General Motors. So to go in detail, I have just put up the highlights of the case which I've already shared with you all. I hope you have seen that case, the document which I have provided to you. So just the highlights I have mentioned in the PPT also. So just you see how this became a case. So the background is on Feb 7, 2014, General Motors recalled about 800,000 of its small cars due to faulty ignition switches, which could shut off the engine during driving and thereby prevent the airbags from inflating. So the problem was that ignition. What is ignition switch? Let me explain. Ignition switch is something which most of you are aware of. That when you would like to switch on a car, you have to put the key in the. When you put the key, that is called, and you rotate the key, that is the actually ignition switch, which allows you to change the mode of the car to start or to off, or to go in the accessory mode, or to in the run mode, right? So this was the ignition switch issue. And what happened? Recalling the cars. Recalling the cars means there is some defect, and which original equipment manufacturer has to rectify. So they recalled all the cars, especially 800,000 cars, due to the faulty ignition switch, right? Which could shut off the engine during driving and thereby prevent the airbags from inflating. So when you are, just imagine when you are driving and suddenly the car moved out into the shutdown mode, or I mean to the off mode, it will be jerk, right? And if you are in the crowdy, or you can say if you're driving in the road where multiple people are also driving, if suddenly your car shut down in the traffic, what it may cause to the it may cause multiple accidents, injuries, and that actually happened due to faulty ignition switch. Multiple accidents have been happened due to that. This problem surfaced out and came up as a case, and that is why, and there were several insights of the case, but we'll be discussing some focused insights to discuss in the context of systems engineering, right? So the case was that some accidents happened and people started complaining and filing the legal complaints against the General Motors, and then it became an issue, and this is how we go into the details. So what happened? As of June 30, 2014, General Motors has issued 45 recalls in 2014, which have involved nearly 28 million cars. It's not just one recall, it is 45 recalls in 2014. In total, 28 million cars worldwide and over 24.6 million in the US. So what happened in this scenario is General Motors says it expects to charge $1.2 billion against its second quarter earnings as a result of It's ongoing recalls. So many defects were there in the products, and because of that, they have to bear a lot of cost. I'll be discussing this point, later on. I'm just highlighting it so that we can, come to this point later on also, right? So here in this case, you see, this was the cost which General Motors paid to rectify the errors. So the case background, the reason little things I have already explained. Let us quickly see. The mechanical design of an ignition switch is a result of an engineering trade-off study, common practice to evaluate performance, cost, risk, reliability, and other pertinent factors into a design selection. Most mechanical ignition switches use a device called the detent, which divides the continuous rotation of the switch that would occur without the detent into a small number of discrete positions. That detent, and there is a spring. When they get connected, there is a possibility to apply some torque, twisting motion, to change the mode like off, accessory, run, or start, right? So what has happened? There is a risk that sufficient weight from a heavily loaded keychain, for instance, may inadvertently make the switch turn from one position to the other. The result of the faulty ignition switch turning from on to another mode is a disabling of the power steering capability and preventing airbags from deploying. Just imagine some person is driving a car and immediately the full fledged, let us say in the speed of 70, 75, someone is driving in the highway, and suddenly the car engine gets off, and there are multiple people driving around you in the road, huge traffic. So just imagine that what kind of jerk and what kind of injuries a person can, not the person who is in the car. I mean, the outsider people, outside vehicles also may get impacted. And that is what happened, right? So that was the critical case. So this is the base case problem statement actually, right? That is why it has been named as the ignition switch problem. So I hope everyone is very clear about the problem, right? So this is the case statement. And now we'll go in the details and we'll try to understand that what could be the reason, right? And we'll try to justify with the, or you can say we'll try to justify or identify the flaws with respect to systems engineering, right? So this is a case which has been mentioned by the Stephen in IEEE Technology and Society magazine. And though multiple people have discussed this case in multiple forums, but I found the statements mentioned by Stephen are more relevant to discuss in the class. So I've taken from his paper. Further case details, just a small introduction about General Motors. It's an American multinational automotive manufacturing firm. Its headquarters in Detroit, Michigan, in the United States. General Motors is an original equipment manufacturer of four automobile brands: Chevrolet, Buick, GMC, and Cadillac. So now you see OEM is original equipment manufacturer. It means the brand name is of General Motors. So if they are selling some product in the market, it doesn't matter that who has developed the components, or you know who has developed the different subcomponents or subsystems of the whole car, but it has been named as a General Motors product. So it is a responsibility of the General Motors company to take the responsibility of each and every component, subcomponents, or systems in their products, right? Though this ignition switch, when we, I mean, because I know, so I'm discussing it. Just imagine one any product. I hope you know the concept of outsourcing, right? In the concept of outsourcing, what happens that we say that you know, let us say I am manufacturer for a car, right? I'm a manufacturer of a car, and in that particular car, there are multiple systems: electrical system, electronic, mechanical, pneumatic systems, hydraulic systems. Multiple systems are there, right? So what happens that let us say I means as a firm, this particular people who are in this firm are very good at manufacturing of pneumatic systems or very good at assembling the components, right? So what happens is that the companies outsource some of the subsystems to outside vendors. That is called outsourcing. They say whatever I am best at or I am good at, I'll do on my own in my own company. But let us say there are some subsystems which I'm not very good at, means my company is not very good at, my people who or my machines or my infrastructure is not compatible to develop or manufacture those components. So in those cases, let us say I found that in some X country, this company is very good, or these people are very good in manufacturing this type of products or subsystems. So I outsource that component that you kindly take it this design from us as per my design specification. You kindly develop this in your firm, in your place, and supply as the subsystem which you have developed for us. And we will check all the technical specifications and then we will apply it in our final product. This is how things happens. This is how the complex products get manufactured. Everything cannot be done by the same OEM, though it is the responsibility of original equipment manufacturer to check the technical specifications properly, do all the possible quality checks before putting it or before accepting it for the final assembly, right? All the logical relationships, functionality must be checked, right? So this is how these four brands are, mm, I don't know whether it is, yeah, I think it's still, these products are going on. In India, Chevrolet is very common. So GM is an OEM of these four popular brands, and out of these four, I think Chevrolet is more common. Along with this, what are the more inside of this case is General Motors reported significant losses in 2000s, and then GM was concerned about cost cuttings. Due to their losses, they were concerned about the cost cuttings. So when they were concerned about the cost cuttings, what did they do? They started cutting the cost from the production, right? They started asking their suppliers to reduce the cost, right? And then even not in their products, they started cost cutting in the in the welfare schemes of their employees, like healthcare and pension funds are also started reducing, right? So this is this is the scene that what was happening with the General Motors then, because the company and their the impact will be coming in their products also. So what was happening wrong? You see now here in this particular slide, if you try to understand, if you remember, how did I discuss about the this type of systems? So this is basically an organization system, right? Social system, rather you can say. So here in this case, it's a manufacturing organization system, and in this organization system, what kind of things which are not falling well? You see here, they all the stakeholders of the companies were facing the money deficit, right? And because of that, multiple cost cuttings were happening. And now again you reanalyze the system so you will understand, the way I gave you an example, that some of the subsystems of these cars or these automobile vehicles were manufactured by General Motors, but multiple other subsystems were outsourced to outside suppliers also, right? And this outside suppliers were responsible to manufacture those subsystems as per the technical specifications. And cost cutting was applied to those outsourced production, or you can say the external supplier production also. This is how the scenario of organization system. These details are explaining about a company, about a organization system, right? And then if you move on further, technical insights. The ignition switch was a vital component, yes. It seems a very small component of a huge product, complex product. Ignition switch having hardly 5 to 7 components in this small subsystem. Ignition switch do not have more than 7 to 8 components. Small, portion, small component. And now you see the problem was the driver would rotate the key from the off position into one of several other positions. The torque required was very low. With the small torque, small twisting force, it may easily moving to other modes, right? And there is a small, component called detent in this ignition switch. And the problem has been found out in those particular domains, the detent and the spring. These two components have been found out that there was a issue in these particular components. The critical issue in the design of the switch regarded the amount of force that was needed to rotate the switch into the various positions and whether the switch would stay in the correct position while the vehicle was being operated. So they, though in multiple news they say that don't use the heavy keychains, but this is not the, this is not the way to ask your customers that do not use this. Then which kind of flexibility is there in your design? Which kind of robustness is there in your design? If the heavy keychain will be used by some customer, it will be moving to the different mode. This which is not desirable, right? So there were certain risks involved. It's not only life of the people. So with this particular system, right, when the subsystems in the car lose the power, what will happen? It will definitely lose the anti-lock brake system. It will lose the ignition circuit power, right? It will lose the access to the airbags. Everything will be stopped functioning. So this is how these are the technical insights. Further, GM report on the issue was also understood that what GM or General Motors reported on this particular issue, how the OEM addressed the case. So they reported to the National Highway Traffic Safety Administration about this problem, and they mentioned that it is the issue due to the torque performance of the ignition switch. And then they say that we were expecting the technical parameter to be designed to apply the required torque of 20 Newton centimeter to turn the switch. But actually, it was designed for the lesser torque. The technical specification was correct, but the design of that particular subcomponent was not appropriate. So there are multiple researchers who studied the case of General Motors and what happened. So let us quickly see. You see, I think it is uh, Eifler and his team who discussed this case investigations. And what did they do is they took the 10 samples of that particular ignition switch, right? And they measured the single component height, and then they measured the assembled height. The detent and spring and everything was there in the final ignition switch. Then they observed that the height of the single component and the height of the assembled component, the height of the single component was closer to the nominal value, right? While in the case after assembly, the nominal value and the height was not matching. So here if you see, in total 10 samples were taken to measure the height of single component, that is H1. And you see in this graph, Eichler has and his team has defined clearly that among all those 10 samples, 11 samples, what has happened? That these are values are within the specifications. But when the overall height after assembling is calculated, and when you see that overall height after assembling has been measured H2, which the nominal value was here, which and all the samples were exceeding the specified normal value in all the 10 samples, right? So that has been caught as the major root cause, which is the geometric variations. So the final divide, and this has been identified that due to the size of the spring. Okay, so these are just part. I mean, these are some insights to make you understand how we utilize the things, right? How we utilize the concept of systems engineering. So this is how we analyze the systems, especially when the technical failures are happening in your product. So mismatch in technical specifications. What do you mean? So it was clear cut a case of technical mismatch of technical specifications in the product, right? So it clearly indicates that there are flaws in quality management process. What do you understand by quality management process? As we already know, the quality management process consists quality planning, right? And then while execution of the manufacturing, we try to assure whatever quality plans we are having, all the quality standards, all the requirements as per the quality standards. We follow everything, and we try to assure that everything must follow, must align with the quality requirements. And then after the product is manufactured, we try to do the quality control. If there is any defect, if there are any issues, we try to mitigate those issues in the final product. So that is all. Or we try to prove that it is defect free. Or if there is a defect, we try to rectify. That is called quality control. So in the quality management process, if any of these three phases are not implemented properly, it immediately indicates that there are flaws in the quality management process of a manufactured system or a engineering system, right? Then the second thing which we can easily notice in this case is insufficient robustness checks in the product design and the product manufacturing. When you mention something in the technical design and when the prototype is ready, when the things are manufactured and you are now assembling into the final product, it becomes very important to check the robustness. It was very easy. The torque required to move this was higher. but due to the defect in the ignition switch, in the smaller torque also, the switch was or the modes were getting changed very easily. So there is a flaw in the robustness checks. There are multiple methods which you have already seen in previous lectures that may be related to the sensitivity analysis, tolerance stack-ups, design clarity, robust design optimization, multi-objective optimization algorithms, Monte Carlo analysis, etc. We can perform on systems functional parameters simultaneously to cover the entire systems range. Different functionalities are there, and for different functionality checks, we can utilize different methods, right? So this is how things can be done, means should be done, right? But how much we follow, that is a question mark here. In this case, you see how the IFLR has defined these two things. If you see now, I mean, as a systems engineer, so far whatever we have studied, you try to see the case, what should be your observation. So I request all of you to please jot down your thoughts. These are some things which I have discussed. So now I will try to discuss what is quality management process and what are the problems which are related to quality and how the General Motors got affected. If you remember, I highlighted one line in the starting of this case. So let me discuss that in detail. You see, there is a cost of quality all the time. Cost of quality means you invest on two things. Cost means simple investment on quality. You may need to invest on two things: cost of conformance and cost of non-conformance. Conformance means when your technical specifications are all okay, as you decided, as you require in your product. Everything is as per requirement. Requirement of what? Technical specification, or you can say the quality requirements. Then another segment is called cost of non-conformance. When anything got mismatched, or when you can say that this technical specification or this particular things could not be conformed. Cost of non-conformance. Many people say it's a cost of good quality or cost of bad quality also. Cost of conformance is again divided into two. One is prevention cost, right? Another is appraisal cost. Prevention means we do not we try to minimize the possibility of defects. We try to maintain all the technical specifications properly. We'll keep on checking. We do the quality assurance so often. As per my quality plan, everything be assured that whatever we have mentioned in our quality planning checklist, every single piece is checked against that quality requirements and everything is all fine. With this approach, you may minimize the occurrence of defects, or you can say you try to prevent the defects in your products or components, right? But at the same time, there is one more cost that is called appraisal cost. Appraisal cost is that how will you do it, right? How will you promote quality assurance checks? You invest in promoting the quality assurance check. And then you talk about cost of non-conformance. Again, it is of two types: internal failure cost or external failure cost. So, example of prevention cost: training. You invest to train your people, to train your teams, whether it's manufacturing unit or quality check people or whomsoever, the stakeholder, direct stakeholder of the production unit. We always try to train them properly so that they know that what is the document process, right equipments should be purchased. Then we try to invest in the quality planning and proper quality assurance processes. So this all these processes or all these things require some particular investment of money, right? And then appraisal cost. We try to test or inspection of all the resources, whatever we have purchased from outside. We invest to monitor, to inspect that whatever components we are receiving, whatever raw material I'm receiving, whatever inputs, like let us say the components, the equipments, the testing devices, and all other resources, direct or indirect resources to my production or to my manufacturing plant, all should be meeting to my technical requirement. This is how we try to reduce our defects in our final product or components, right? We have to evaluate our suppliers and customers time to time, right? So this is the way we try to invest in the appraisal cost, right? But in the next slide, if you see the cost of non-conformance, it is all good. You see, this particular segment is defining that everything is for good. Good means everything is for the betterment, improvements. But on the next side, if you see cost of non-conformance, internal failure and external failure, it means you tried, though if you are investing in the cost of conformance or cost of good quality, you have invested in the prevention cost, appraisal cost, everything invested. It doesn't guarantee that there will be no defect in the final manufactured product. But if the components get failed while doing the quality control checks, quality inspections, final inspections, if the product has been found that it is having defect, so what can be done? Investment can be required in rework, or if you scrap that particular component, even then your money is you are losing your money, right? Then it is the amount, maybe there may be multiple wastage also. Then spend money in understanding that why this failure has happened. You analyze that failure, right? So these all again consume the money. But at the other side, external failure cost, which has happened in this case of General Motors ignition switch problem, is external failure cost, which is severe than any other investment. Why? Because it includes the liabilities of returned product. Multiple returns, multiple complaints are arising due to the faulty component. And if the product is in warranty, you have to serve your customers for free, right? Then if the complaints are more, you may be losing your business also. And that may be more negative impact than all. So this is how this particular box is the super red, right? It's a dangerous thing. In this case, same thing has happened with the General Motor also. So now, if you remember the line which I have highlighted, what is it? I talked about a highlighted line. You see here, GM says, General Motors says it expects to charge $1.2 billion against its second quarter earnings as a result of its ongoing recalls. You see, what is this $1.2 billion here? I should rather say this is the cost of external failure. Very nice example of external failure cost, right? If they could have invested this $1.2 billion in cost of conformance, in training their people, in having better equipments or better measurements, or if they could have converted this failure in the internal failure cost, it could be much cheaper. But now you see what is happening. They are raising 45 recalls in the whole year. 45 recalls means huge number of complaints, multiple accidents are happening, multiple people are dying also, right? So this is becoming a legal case, right? So this is how the quality in the systems engineering cannot be missed out. And as we have seen in the House of Quality also, I think everything has been discussed in that lecture. You may review that session, right? So here I'm just trying to talk about quality management process and how it may impact and how it is related to the cost, right? So here in this case, we are actually seeing that what is the external failure cost in this case, right? Then you see mismatch in technical specifications. What else it indicates? One thing we have seen, quality angle we have seen. So the General Motors were facing the external failure cost of quality. Misalignment of systems complexity with systems robustness. System was complex, but it was not aligned with its robustness. Robustness checks were missed out. So here, I would rather suggest that axiomatic designs may help understanding the robustness and complexity simultaneously. Then again, as we have seen, a model-based approach, MBSE, can help in defining the requirements with respect to their functionality. RFLP, the requirements with respect to their functionality F, logical relationships L, and then the physical conversion to physical designs PE. If you relate the RFLP approach or model-based systems design, it can be helped in designing the flexibility of the system. If you change one single technical specification, how it is going to impact the whole system, that can be easily monitored if you are applying or following the model-based approach, right? So if you see MBSE describes the functional coupling and supports the verification and validation in all steps. So here in this case, in this particular case, if you try to understand that verification and validation things may not be there, that could be the reason that a faulty component got installed in the final product and sold to the customers, right? So these are some angles of understanding this particular case with the eye of systems engineer. And along with this, you see, engineers must thoroughly test and validate all the designs, and that is how in MBSE it is clearly, the clearly having that functionality. One researcher, Wohler has discussed this model-based approach to associate the complexity and robustness in engineered systems. Wohler et al. Has attempted so well in discussing the relationship of complexity and robustness. Multiple model-based approaches they have discussed in their paper. You may refer that. So these were the technical insights. Along with that, there were some other aspects which we have seen, like stakeholder analysis. Remember stakeholder analysis? I think there was one dedicated session on this also. You know that who are the stakeholders, right? And especially who are the key stakeholders, what are their requirements, what are their needs, and how your product is going to fulfill their requirements. Then the lack in communication, focus on cost over safety. General Motors were more focused on reducing the cost cuttings were their main focus, right? Then ignorance of social responsibilities. When your key stakeholders or when your users are using your product, which can be more fatal, where the life is involved, where the health is involved, right? Or especially the masses are using your products. So then in that case, social responsibilities are also a side which we cannot ignore. And among all, the topmost is the improper risk management. The risk management in the whole, product development, and you can say the product manufacturing, assembling, and developing the whole engineered system for ready to use and declaring it in the market, selling it to the people everywhere. Risk was involved, and the risk assessments were little weaker in this case because the results are showing that there is a clear cut case of improper risk management. So some of the further readings are shared. You may discuss. These are just few lists which I found more relevant in the context of systems engineering. In this case, you may read all these papers to find out that how researchers have reviewed these cases, and you may try to identify that what can be methodologies or what could be the better way to avoid these kind of faults or defects in your design or in the product, right? So these are some related articles and some related discussions which people have made and which people have offered. It may bring more understanding to you. So now I would like to state one common statement here that after discussing this case, you feel that it's not just General Motors case. There are multiple automobile recalls happen in the world, right? If we try to just focus, this is not just one case of General Motors of emission switch issue and recalling multiple cars, but there are many cases. One General Motor cars which we have already seen. The case we just discussed was of 2014, but here you see this is one more case again in 2020, and again it was related to those cars which were developed in later years, right? And it was again due to the faulty airbags. So one case in the cars which have been developed in 2005 and 2007 and 2000s, the results were upcoming in 2014 and the recalls were started in 2014, the ignition switch case we just discussed. But even after that, the models which got manufactured within the range of 2014 to 2017, again the recalls were there for the faulty airbags. Further, it's not just General Motors. And in the case of Mercedes Benz, you see that in January 2020, they announced, especially Mercedes Benz India announced a recall for current generation E Class and C Class models. And this was due to the fire risk of unburned fuel, which may be catalytic converter in certain driving conditions. You see different causes, different kind of defects, right? Toyota Motors, right? It is not limited to just one company. Recalls, especially for the four-wheelers, is very common. Again, you see Maruti Suzuki. They're also, started recalling the cars in 2020s. Here also, you see it is again the case of 2020 also only, right? So this is how the reasons may be different. In this case, if you see, it was including, in this case, if you see, due to faulty fuel pumps. In the case of Maruti Suzuki, you see, it is again due to the faulty fuel pump, right? So you see, the reasons may be different, the causes may be different, but ultimately the whole systems are getting impacted due to a small fault. The whole system is functioning differently. So can you now say that a small component or a small subsystem is having a significant role in the whole system? So that is the reason why systems approach is becoming very, very important. Otherwise, it may be creating the fatal effects in the society and the users or on the organizations. It is, taking a lot of money to rectify the errors, right? So now I would rather try to ask you that so far, whatever we have understood in this particular program, in this particular course. I hope you are getting the practical applicability of this course or the system's thought, right? I'm sure you must be learning, yes, right? So, systems engineer must not only think about, the certain engineering aspects, but along with the systems thought, the systems engineer must be very sure about the quality attributes like security, right? The performance, the electromagnetic interference, and the mass volume requirements. Everything must be considered, all the quality attributes must be considered by the systems engineer. Along, not only this, they should be very clear, very thorough about the understanding of the quality attributes, whether it's life cycle cost, development schedule, or any kind of engineering related aspects or non-engineering aspects. They should behave as a systems engineer, and they should be giving the insights about the relevance of a small subsystem in a huge system. Then, if there is, you may also see on your own if you are interested in this kind of case studies. You may see that this is the voluntary recall website in India, where we always get the information that what kind of recalls are happening and why. With the reason, you see here the manufacturer names is mentioned, then the voluntary recall date, model, variant, and this is a public recall that whomsoever is utilizing this kind of product, they should come and return this particular product which have been manufactured from this to this date. They define the description, what is the defect in their product. So if you see, there are huge number of list of recalls. So can I say in conclusion that there is a dearth of systems thought or dearth of systems engineer in the production units or in the design units? I'm not sure. I'm not marketing the systems engineering job requirement. But yes, I think it is, because systems engineering is not just one domain, it's a multidisciplinary, interdisciplinary domain. And today in your institute, you may be mechanical engineer, electrical engineer, electronics engineer, but at the end, if you are not understanding the whole system, there will be the misalignments will keep going on in the production, in the designs, and everywhere. And at the end, will be resulting into the defects if we lose the thought of systems, right? So this is not limited to the automobiles. It is more severe. The accidents and the defects happens in the aircrafts also. So there's one more case. If you remember the very first introductory slide, this case was also mentioned, listed in that slide. That was the Boeing 737 issue, right? The two 737 MAX crashes resulted in the loss of 346 lives, right? So there were the issues related to the designs. These crashes have been occurred, and they have, these fatal accidents actually cost a lot. It is the people lives, it is the cost of manufacturing that particular product, the efforts, the money, everything is all gone, right? So you see, the incidents led to extensive investigation and scrutiny of Boeing's design, manufacturing, and safety processes. After this, result, the detailed discussions and investigations happened. Then the Boeing's leadership faced pressure, including the resignation of the CEO and different other, multiple things happened in the Boeing because of this fatal accident. And then it became into the news, and multiple engineers like us studied the case. Considering the time constraint, I'm just, directly moving into the critical points. So the case summary in this case was lack of systems engineering approaches. They designed everything so well, but the alignment, the what was the problem actually? Let us see the problem. So in this case, the problem was that they have put up the engine above the wing. The location of the engine was improper. What do we do in the model based systems engineering? We always try to bring out the connections in such a way that practical things are coming up into our designs as well. And we try to make the things logically right. Here, what happened that they have the major issue, you see, maneuvering characteristics augmentation system. Design issues prevented stalls. Now you have kept the engine in such a location which is making the aircraft unbalanced in the air. And due to that, misalignment of the engine should be below the wings always. But the engine was aligned in such a way in that particular aircraft that it was above the center of gravity issue occurred actually, right? So the main feature of the aircraft is its maneuvering. Maneuvering means the yaw, then the pitch and the rotations, right? So with respect to three axes, how the aircraft is moving. So yaw, pitch, and the roll. These are aircraft maneuvering includes the three basic roles: yaw, pitch, and roll. And while aircraft was on the air, it prevented the stalls as it was based on data from a single angle of attack sensor. This created a single point of failure as a malfunctioning sensor. So what happened due to the mismatch of center of gravity? Things were not working well in this case. So further things are like pilot training, communication, focus on cost over safety once again, same here causes, right? The small misalignment, right? And what happened due to this malfunctioning, the maneuvering characteristics could not be performed by the aircraft, and that causes the accidents, right? So these are just some examples, some cases which these are the publicly open cases which came to our cognizance, but there are multiple defects which may come up in the internal failure cost category, which could not get public, right? And which are within the organizations. So what I'm trying to make you explain here is that this is our role, this is a systems engineer role, to understand all the possible aspects, right, with the systems engineering thought. Okay. And these are just two cases which we discuss in the class, but there are multiple more and more cases which we can see in different forums. Okay. And I am sure that these cases will provoke your thought to apply multifaceted angles in order to make the robust systems with the design flexibility. So I'm sure we started with the design flexibility, and I think by now you may be understanding that how we are applying all these things in the systems engineering. So now we came to the end. I'm really very happy to conclude this session finally with these two cases, right? And I'm sure that you must have learned a lot. So, in conclusion, in this course, we have talked about products, we have talked about systems, we have talked about engineering, algorithm, optimizations, right, axioms. Then we talked about the adoption, then the user understanding, then the understanding your stakeholders, stakeholder needs assessment. And I think there are multiple, design structure metrics, system dynamic modeling, database systems engineering. I hope that you have been introduced to multiple angles of systems engineering, and I'm sure that you must be learning across all the program by Professor Vijitashwa Pandey and by me. It is my pleasure to conclude the course today, and I'm thankful to the GIAN team and Minister of Education to sponsor this program. And I'm thankful to all of you for joining this course for the 2 weeks long program. And I'm thankful to the foreign faculty, Professor Vijitashwa Pandey, to join us and share his thoughts and for his lectures on this particular course. And I'm sure all of you must have taken the benefits from these sessions in your future, and will definitely apply these in your work also, right? So at the end, I'm just sharing some list of references and textbooks. Though we have mentioned all the resources in the particular topic also, but you may refer these books as well for understanding the details of content which we have discussed so far in this particular 2 weeks course, right? So at the end, I would like to thank you, all of you. Thanks to ITISM team to support throughout the program. Okay. So your certificate distribution and other things will be happening in some time soon. Thank you so much.